Okay, so the purpose of this video is to help you draw angles, rotations, reference triangles, reference angles, and know what quadrant an angle falls in. Um, so what we've got here is I've got a couple of sketches here, and I took pictures of my right hand, and what I want you to be able to see is this positive x-axis. That's always where we start. That's called the initial ray, because we get angles, so they have two rays, right? That's called the initial ray. We always start at the x-axis. And if you have a positive angle, like if they want us to sketch a 30-degree reference, 30-degree angle, we're going to start right here. And here, let me get a pointer going, and go to the right. Go like this. We're going to go around the axes like this. We're rotating it around. And then what happens? We have a terminal ray, and the terminal ray is where the angle ends. So I draw that. So this is the terminal ray, and it's wherever it falls. Terminal ray. I know that you can't read my writing, but and that's where the angle ends. You have the initial ray on the x-axis, and wherever the angle ends is the terminal ray. And then that terminal ray can fall in the four different quadrants of a Cartesian plane. So we got quadrant one here, first quadrant. You probably know this already. The second quadrant's here, third quadrant's here, fourth quadrant's down here. And then we go back around in the first quadrant, second quadrant, third quadrant, so on and so forth. And then the same thing, even with the negative angular rotation, it's still the same quadrant number. It's just that you're headed around it this way. Start at that initial x-axis, that positive x-axis, the initial ray, and then wherever it ends up is where it falls. And the reason I took these pictures of my hand, this is called the right hand rule. And if you get confused about what is a positive angle of rotation, what's a negative angle of rotation, put your hand with a thumb pointing up, because thumbs up is good. And this is the way, see the way my fingers are curling? That's the way a positive angle of rotation goes. And then thumbs down is negative, and that's the way, see the way my fingers are curled? That's the way a negative angle of rotation goes. And it's that easy. We'll never probably use that again, but it does help. All right, so what have we got? We've got angular rotation, we have positive negative angular rotation. We talked about initial rays, terminal rays. Maybe we should do some sketch some angles. So I've got to do some, let's do this, and we're gonna sketch some, reference angles. We're gonna decide what quadrant the terminal ray falls in, and then I guess I can talk about quadrantial angles too. I didn't do that today with my pre-calculus class. I guess we'll do it the next time we see them. So when you're doing an angular rotation, you could ask yourself, first thing, you're going to make an XY axis. Oh, that's interesting that did that. Did they updated the software? It's the first time I've used it since it's been updated. So I'm going to start here. Let's sketch that 30-degree angular rotation. So I'm going to sketch that angular rotation, and remember, this is 0, 90 degrees, 180 degrees, 270 degrees, then we're back to 360 degrees, right? So 30 degrees will fall about there. And so there's my terminal ray. See the way I do that little arc with an arrow? So this angle, that's positive 30-degree angular rotation, landed in quadrant one. How about this 210-degree angular rotation? So 210, I'm going to walk here. There's 90. Here's 180. 210 is going to fall down here. So that 210 angle of rotation, positive angle of rotation, will land in quadrant three. And I guess that's it. It's not a quadrantial angle. We'll talk about that is in a second. Okay. Let's do some more. Let me delete these and we'll do a couple more. Okay, so then we've got, suppose I've got to go around more than 180 degrees or more than 360 degrees. So I'm going to start here. I'm going to go, there's 360 degrees. So then we're going to say, what's 515 minus 360? And I'll do a little arithmetic and hopefully I can do this correctly. So that's 0. So 50 minus 36, I think, is 145, 140. So that's a 145. That's not right, is it? It was 0, and and make that be 4. Yeah, that's 145. So we're going to have to go 145 degrees more, which is going to be right about there. There's my angular rotation, and it lands in quadrant 2. Okay, and see where I kept going. How about let's do a negative angular rotation. We haven't done that yet. How about negative 190? So negative 190, I'm going to start here. There's negative 90, negative 180, negative 190. So that's going to be that. That's going to be yeah. So that's going to land in quadrant 2. And I guess that's all we need to talk about this for now. Okay. And same deal. If you're going to do a negative 650, you just keep going around, and you got to keep subtracting 360 until you get there. Okay, I guess the next thing we're going to do is I got to talk to you about quadrantal angles. I also have to talk to you about um, reference triangles, reference angles, and then we'll be good to go. Okay, so anytime you have an angular rotation and it lands on one of the axes, that's a quadrantal angle. So 90 degrees is a quadrantal angle, 180 degrees is a quadrantal angle, 270 is a quadrantal angle, negative 270 is a quadrantal angle. How about 450? So we go around once, that's 360. What's 450 minus 360? That's going to be 0, and isn't that 90? Isn't that 15? That's 9. So 90 degrees. So 450 is also a quadrantal angle. We didn't know that until we did that sketching around. And there's quadrantal angles are cool. We're going to use them a lot, but you can't draw what I'm going to show you next. Okay, so recognizing a quadrantal angle helps you out. Now the next thing we're going to talk about, how do I find the reference triangle? Reference triangle. You have to be able to find the reference angle. And I guess that's good. So how about if I have what if I have a angle of rotation of 150 degrees? And they want me to find the reference, draw the reference triangle and find the reference angle. So I'm going to start here. Remember, this is 90, and this is 180, and this is 270 and 0. So 150 is going to be about there. Now, when you draw the reference triangle, you always go back to the x-axis. Somebody on a quiz is going to do this, and that's not what you do. It's always back to the x-axis, okay? So then, once you know that, to find that reference angle, well, that's the reference angle right there. And the way we get that, my earbud fell out. The way we get that is we're going to take 180 and we're going to subtract the 150 degrees. So that reference angle right there is a 30-degree angle. Okay. How about if we have a 335-degree angle? If you want, while I'm clearing this up, you could try that. Think about that, and then nope, I got to do some deleting here. Just a minute. How do I do that? Do this, select that, delete. There we go. Here's this. 335 is going to be, well, I know that's 270. I know that's 360. So I know a 335-degree angle is going to be right about here. Here's the angle. Here's my reference triangle. I'm coming back to the x-axis. So now I've got to find this angle here. Well, in this angle, in this quadrant, we've gone all the way around here, so we got to figure out what's left. So in this case, it'll be 360 minus 335. And I'm pretty sure that's a 45-degree reference angle. Okay? That's that easy. Okay, and I'm sure we could do some more. I don't know how, if you wanted me to write one, we can try it here. Why don't you try to find draw the reference triangle and find the reference angle for a 750-degree angular rotation. I'll do some erasing. No. Okay. So what I just drew is 720 degrees, right? So I'm going to go 30 degrees more to get the angle. So that means I'm going to come back to the x-axis for the reference triangle. And of course, I've gone 750 degrees around, but two rotations are 720. That's going to give me a 30-degree reference angle. So that reference angle is 30 degrees. Piece of cake. In fact, why don't I give you guys, I haven't done this yet, why don't I give you this set of shortcuts? You probably won't use them once you get it down, but if I have an angular rotation, we usually talk about them as the angle theta. If it's here if it lands in quadrant 1, the angle is the reference angle. If it's over here in quadrant 2, it's going to be 180 minus the angle. Down here in quadrant 3, it's going to be the angle minus 180. And over here, it's going to be 360 minus the angle. Okay, so it's that easy. And even if you have a negative angle of rotation, it's very similar. If you have a negative angle, we're going this way, remember. In this case, it'll be the absolute value of the angle, because if it's a negative 30 degrees, the reference angle is 30 degrees. If it's over here, we're going to do 180 minus that absolute value of the angle. Here, we're going to do the absolute value of the angle minus 180. And over here, we're going to do 360 minus that absolute value of the angle. And that's how you do the negative angles of rotation. Okay, and really that's about all there is to this. Oh, the quadrantal angles. Got to just talk about that. So with a quadrantal angle, you can't draw a reference triangle and reference angle. Okay, if it's a quadrantal angle, you're done. I can't draw a triangle because there's only the one leg, right? There's only the one ray. There's no other ray to come off anywhere. So keep that in mind. And actually, it's really nice when we start working with sine and cosine and tangent, secant, cosecant, and cotangent of angles. And when you have a quadrantal angle. Okay, so that's about it for that section. Now, if you're one of my high school students, just a minute, you have this handout, and I'd like you to complete it. At least complete the odds. It's in your packet. I'll also make this, if you're in one of my CCV college classes, pre-calc classes, I'll also have this available. There's also a My Open Math assignment you can do rather than doing this, but paper practice is always good. Okay, hopefully this helps, and give me a yell if you need any help.